All right, after our last video, we found out a lot of information, a lot of definitions of our shapes of our figures. So now we can use that information to say things about those figures then. So for example 1, if we are given trapezoid Z, Y, X, W, so this figure right here, and they told us that angle Y, so this angle right here, was equal to 3x plus 19, and angle X equals x plus 1. That would be this angle right here. Underline this one in red. We need to find the measure of these two angles. Notice they didn't say find what x equals. We're going to need to solve for x, but in the end, we're looking for the measure of these two angles. Okay? So, to do that, we need to use our information and say y plus x, so this angle plus this angle, has to equal 180 degrees. Because, well, if this is a trapezoid, that means this line and this line are parallel. If these are parallel, then these two are same side interior angles. And the same side interior angles have to be supplementary. Okay, because these are parallel, that implies, or that tells us, that these ones have to be supplementary. So that's why we can say this is true for sure. Well, we also know that y is the same thing as 3x plus 19, and angle x is the same as x plus 1. So we can just substitute those values in right here for y and here for angle x. So now all of this equals 180. Simplifying it down, 3x and this x over here would combine to 4x. 19 and 1 would combine to 20. So we have 4x plus 20 equals 180. Subtract 20 from both sides, and we have 4x equals 160. Divide by 4, and we'd get x equals 40. So we've solved for x, but that doesn't mean that either of these are 40 degrees. We have to plug them back in to find how big each of those angles are. So first off, y equals 3x plus 19, or angle y equals that much. So just plug in 40. Angle y equals 3 times 40 plus 19. 3 times 40 is 120. Then 120 plus 19 would be 139. So angle y equals 139. That would be one of our answers. Okay, looking at angle x now. Angle x is x plus 1. X, we figured out, was 40. So 40 plus 1 is 41. So angle x is 41 degrees. 41 degrees and 139 degrees would add up to 180. So these fit. These two, angle x and angle y, would be 41 and 139 degrees. All right, now we have figure LMNO. And they're asking us, is this actually a trapezoid if we have each of these figures? Now, the first thing I want you to do, they had OLN. I want you to change it to an M. That was a typo there. Just put a little extra line there. Angle OLM is 47 degrees, or that's what they were getting at. So if we label each of these spots, this one is 133. This one is 47. This one is 111. This one is 68. Okay, that's what each of these pieces told us. So we need to decide, would these measurements actually make this a trapezoid? Okay, so we can figure out that LMN and OLM are the same side interior angles. They are also supplementary, because if we add them together, they would equal 180. Since the same side interior angles are supplementary, then we know for sure that these lines are parallel. Now, they drew the lines in, but if they didn't draw those on there, if they didn't say or show that these were parallel, we could say, yes, they have to be parallel because this one and this one are supplementary to each other. Okay? Same thing, MNO, that angle, and angle NOL are same side interior angles, these two right here. Those are also supplementary because we can add them up and get 180. So again, since the same side interior angles are supplementary to each other, then the lines going across there have to be parallel. On a proof, you would use the reason same side interior angles being supplementary. If we know that these are supplementary, then we know for sure that those lines are parallel. They imply parallel lines. So if these actually are parallel lines and we have a quadrilateral, does that make this a trapezoid? Yes. Yes, it is, because we have one pair of parallel lines. Example 3, given that W to X is parallel to Z to Y, and given that W to Z is parallel to X to Y, name this figure and solve for all the remaining sides and angles. Well, because we were told that this is parallel to this one parallel to this, the only figure that matches that description is a parallelogram. So, because it's a parallelogram, angle W is the same as angle Y. Angle Z has to be the same as angle X. We know that for sure because it's a parallelogram. We also know that WX has to be just as big as ZY, and that WZ has to be just as big as XY. So since this one is 250, this one is 250. Since this is 120, this is 120. Same thing. Since this one is 110, this one has to be 110. To find X and Z, though, because it's a quadrilateral, all of these have to add up to 360 degrees. Get rid of that piece. So we would say that 110 plus 110 plus angle X plus angle Z equals 360. We know that angle X equals angle Z because it's a parallelogram, so we can combine those together. 110 plus 110 is 220. X plus, we'll call this one also X. We'll substitute in an X right here. So X plus X is actually 2X. So 220 plus 2X is 360. Subtract 220 from both sides. So it would become 2X equals 140. So X has to be 70, which makes Z also 70 degrees. So these two are 70 degrees, these two are 110 degrees, these two are 250, these two are 120. Example 4, given that DGFE is a rhombus, solve for X and find the remaining angle measures. Well, because it's a rhombus, we know that this side is congruent to this side, is congruent to this side, is congruent to this side. All of them are the same length. So what that tells us for sure then is that 2x plus 9 equals x plus 5, because these are the same exact length. 2x plus 9 is the same as or equal to x plus 5. So I can minus 1x from both sides, and just be left with 1x plus 9 on this side equals no x's plus 5, so just the positive 5 over here. Take away 9 from both sides, and we'd say that x equals negative 4. So that is true. Now to find our angles, oops, pull that down. Angle F has to equal angle D because it's a rhombus. A rhombus would tell us it's technically a parallelogram, so the angles that are across from each other have to be equal. Have to look like that. So if D is 35, then F is also 35. Figured that one out. E has to equal G because it's a rhombus. This is a quadrilateral, so the sum of the interior has to equal 360. So 35 plus angle E plus angle G has to equal 360. 35 and 35 become 70. Again, substituting in angle E for angle G here. E plus E would be 2E. So 2 angle E's plus 70 degrees is 360 degrees. Minus 70 from both sides. 2E equals 290. And dividing by 2 on both sides, we'd find that E equals 145 degrees. And since angle E is the same as angle G, G also equals 145 degrees. So we figured out each of these angles and we solved for X. Figure TUVW is a kite. Because it's a kite, they kind of already drew some of the information in here for us. We're going to do it in color. This one has to be the same as this. This has to be the same as this. And this angle, W, has to be the same as this angle, angle U. So if angle U has to be the same as angle W, and angle W, it says, is 110 degrees, then that value Y has to be 110. So we've solved for Y already. Nice and easy. Because this is a rhombus, we would say that these opposite sides are equal to each other. Or actually, well, let's do the angles first. This is a quadrilateral, so the sum of the interior angles must be 360. 110 plus 110 plus 65 plus this value X that we don't know have to add up to 360. Combine all of these, the 110, 110, and 65, and we would get 285 plus X equals 360. Subtract 285 from both sides, so X equals 75. So here we have our Y, here we have our X. Two pieces already done. Because it's a rhombus, this side has to be the same as this side, so we'd say 3 times the amount Z minus 6, right here, has to equal or be the same as 72. Use our distributive property. 3 times Z is 3Z. 3 times this negative 6, negative 18 or minus 18. Add 18 to both sides. 3Z equals 90. Divide by 3 on both sides. Z equals 30. So we've figured out that piece. From up here, we can see that 31 is the same as 2a minus 5. So 2a minus 5 equals 31 would be our equation that we have to write out. Add 5 to both sides to get rid of that. 2a equals 36. Divide by 2 on both sides, so a equals 18. So we've solved for X right here. We've solved for Y right here. A right here. Z right here. Each piece. Example 6. Example 6 says PQRS is a parallelogram. Solve for X and Y. So parallelogram would tell us that this is parallel to this. This is parallel to this. But that doesn't really help us a whole lot. A parallelogram also tells us, though, that this is congruent to this, and this is congruent to this. Okay, so because parallelogram has all that extra information, we can say these are true for sure. That's helpful because now we know this side is the same as this side. We can set up an equation. PQ equals SR. These have to be the same. So y plus 20 has to equal 3y minus 4. Get that out of the way. So I can subtract y from both sides, or 1y from both sides, and get 20 equals 2y minus 4. Add 4 to both sides. 24 equals 2y. Divide by 2 from both sides, and we get 12 equals y. So we've solved for one of our pieces. We had to solve for x and y. We've got y done. If this is a parallelogram, then PS equals QR. These have to be the same length. So I can set those lengths then. 2x minus 10 equal to x plus 80. Write an equation for that. Subtracting 1x from both sides, I'd get 2x minus 10 equals 80. And adding 10 to both sides, I get that x equals 90. And now I've got everything solved for, x and y. And that'll be it for all of our examples.